Hello students, welcome back to Educator Guru YouTube channel. In my previous video, I had explained about the theory of number system chapter of the subject Bumastics. In this video, I'll explain the theory and problems of LCM and HCF, that is least common multiples and highest common factor. Before starting, I request everyone to subscribe to our YouTube channel and also like, share among your friends who are in need. Thank you. Now, let us start with the number system, part 2 video. Now, common multiples. What do you mean by common multiples? When two or more number multiples contain some common number, they are called as common multiples. Let me explain you with the example. Here, first let us write the common multiples of 2 and 5. Multiples of 2 are 2, 4, 6, 8, 10, 12 and so on. Likewise, multiples of 5 are 5, 10, 15, 20, 25. So here you can see the common multiple is 10 and 20. So these two are found in both the sets. Hence, they are called common multiples of 2 and 5. Now, least common multiple, which is called as LCM. The lowest common multiple of a given number is the smallest number which is divisible by each one of the given number. It is very simple. Let me explain you with an example. I have taken here two numbers, two integers, 3 and 5. So multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27 and so on. Likewise, for 5 it is 5, 10, 15, 20, 25 and 30. Here, you can see the common multiples of 3 and 5 are 15 and 30. So, in these common multiples, the smallest one is 15. So, the LCM of 3 and 5 is 15. This is the crude method, general method of finding the LCM. Hope this is clear to you all. Now, there are various types of finding LCM. First is prime factorization method and the second one is division method. Let us go one by one. So, prime factorization method. In this, we'll break down the numbers into their prime factors by constructing the smallest number with all the factors. For example, the prime factors of 8 are 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Similarly, the factors of 18 are 2, 3 and 3. 2 3s are 6, 6 3s are 18. So the product of highest powers of all prime factors of all the given numbers is taken as LCM. How is it? Let us see further with a problem and an example which will make you understand even better in an easier way. See. Now, I have taken a simple problem. Find prime factors of 18. So, here it is given in two methods. One is division method and factors tree method. So, in division method, first what they have asked prime factors. So, we'll write 18. So, first we have to start with the lowest number. So, the lowest number is first 2. First, we have to check whether is it divisible by that number. Then we'll have to go to the next possible multiple. Next highest number. So here 2 9s are 18. Then it comes to 9. Then 9 is not divisible further by number 2. Then we'll go to the next number 3. So 3 3s is 9. Then 3 1s are 3. So the prime factors of 18 are 2 into 3 into 3. Similarly, in factors method also we can do like in tree shape it is shown. Here it is shown in the division method. That's all. Next. Now let us find LCM of two numbers. This will make you understand even more better. Now first they have asked find the LCM of 12 and 18. 12. Sorry. 12. So the first 2 6s are 12. Then 2 3s are 12. Then 3 1s are 3. So the factors of 12 are 2 into 2 into 3. Then coming to 18, 2 9s are 18, 3 3s are 9, 3 1s are 3. So the factors of 18 are 2 into 3 into 3. So here, if you see factors of 12, we have repeated 2 twice. So we have to take 2 into 2. And here in factors of 18, they have come, 3 has come twice. So 3 square, which is nothing but 3 into 3. So if you multiply 2 into 2 into 3 into 3, it becomes 36. So this is the LCM of 12 and 18. This is the least common multiple of 12 and 18. This is how you find LCM. Now, we'll take 4 numbers. We will find out the least common multiple of 25, 30, 40 and 50. So, first we have to find the prime factors of each number. Then, we'll get the LCM. So, first we have taken 25. So, the first, it is divisible by only 5. It is not divisible by 1, 2, 3 or 4. It is only divisible by 5. 5 5s are 25. Then 5 1s are 5. So the factors are 5 into 5 or 5 to the power 5 square. Then 30. 30 is divisible by 2. 2 15s are 30. Then 3 5s are 15. 5 1s are 5. So factors of 30 are 2 into 3 into 5. Next, coming to 40. 2 20s are 40. Then 2 10s are 20. 2 5s are 10. Here, then 5 is not divisible by 2, 3 or 4. The next number is only 5. So we have to take 5. 5 1s are 5. So the prime factors of 40 are 2 into 2 into 2 into 5. Then 50. 50 is divisible by 2. So 2 25s are. Then 25 is not divisible by 3, 2 or 4. Next we have to consider only 5. 5 5s are 25. Then 5 1s are 5. Hence the multiples, the factors of 50 are 2 into 5 into 5. So now the LCM is 5 has been repeated in every number. So the maximum number of times it has repeated is 2. So 5 into 5. Then 3 has repeated only once in the number 30. So you have to consider only for one time. Then 2 has repeated thrice in number 40. While finding the factors of 40, it has appeared 3 times. So we have to consider 3 times 2. So it becomes 5 into 5 into 2 into 2 into 2 into 3, which is 600. So the least common multiple among 25, 30, 40 and 50 is 600. Next, we also have division method. The second type is division method. In this method, divide the given numbers by common prime number until the remainder is a prime number or 1. So first, let us see the procedure of finding LCM by using the division method. The first step is, first write down all the numbers by separating them by commas or using commas. Then divide all the numbers by the smallest prime number. 1, 2, 3, 5, like that. Then step 3, if any number is not divisible by such prime number, then write down the number as it is and proceed further with the other numbers. Then keep on dividing the rows of the numbers by prime numbers unless you get the result as 1 in the last row. So you'll get clarity of these steps when you solve the problem. Let me take a problem and explain you, which will be very easy for you to understand. Find the LCM of 18 and 24 by division method. So as told in the previous slide, we have to write the numbers by separating them by using a comma. So I have separated by using comma 18, 24. Then first least prime number that is divisible for both 18 and 24 is 2. 2 9s are 18, 2 12s are 24. Then 2 is 2 can be used to divide 12 but not 9. So write the 9 number as it is and divide 12 with 2. 2 6 are 12. Then 2 3s are 6. Write the 9 number as it is. Then the remainder is 9 and 3. So here you cannot use the prime number 2 to divide either 9 or 3. Then the next prime number is 3. So 3 3s are 9, 3 1s are 3. Then 3 1s are 3. So the remainder is 1. So till here you have to follow this procedure in division method. So next, how to find LCM? After this procedure, you have to multiply 2 into 2 into 2 into 3 into 3. This first you have to write, and when you multiply, the answer becomes 72. So this is the LCM, least common multiple for 18 and 24. We'll see some more problems which will make you feel better and understand easy in an easier way. Next, I have taken here 5 numbers. Find the LCM of 12, 25, 40, 75 and 100 by division method. So, division method is the method where you calculate LCM by finding the factors in the same table by separating them by using a comma. So, first you have to write 12, 25, 40, 75 and 100. Then start dividing from the least prime number. First one is 2. 2 6 are 12, 25 is not divisible. Then 2 20s are 40, 75 is not divisible. Then 2 50s are 100. Next, again you have some numbers which can be divisible by 2. So 2 3s are 6, then 25 is not divisible, so write as it is. Then 2 10s are 20, 75 is not also not divisible, so write as it is. Then 2 25s are 50. Then among 3, 25, 10, 75 and 25, only 10 is divisible by 2. So 2 5s are 10. Other numbers remain constant. Then in the next step, the numbers are 3, 25, 5, 75 and 25, which is not divisible by number 2. So we have to go to the next prime number, which is 3. So 3 1s are 3, then 25, 5 is not divisible by 3. Then 3 25s are 75. That is reduced. Then again 25 is not divisible by 3. So the remainder becomes 1, 25, 5, 25, 25. So these numbers are not divisible by either 2, 3 or 4. So the next prime number is 5. So 5 5s are 25, 5 1s are 5, 5 5s are 25, 5 5s are 25. Likewise, if you do, you will get the remainder as 1. So the LCM for 12, 25, 40, 75 and 100 is 2 into 2 into 2 into 3 into 5 into 5, which is 600. So the least common multiple among 12, 25, 40, 75 and 100 is 600. Next, let us go to highest common factor or greatest common divisor, which is nothing but HCF. It is the largest number that completely divides all the given numbers. The highest common factor is determined by identifying all common factors between 2 or more numbers. Let me explain you with an example. See, here they have asked to find out the HCF of 9 and 12. So first you have to write the factors of each number. The factors of 9 are 1, 3 and 9. Then factors of 12, 1, 2, 3, 4, 6 and 12. Here the common factors are 1 and 3. So in the common factors 1 and 3, the highest factor is 3. So therefore the HCF between 9 and 12 is 3. Hope this is clear to you all. It is a very simple example. Keeping this in mind, we'll solve some problems on HCF. In HCF also we have 2 methods of finding. One is prime factorization method. The second one is division method. Let us see one by one. Prime factorization method. The following is the procedure to find out HCF by using prime factorization method. Step 1. First, find out the prime factors of the given numbers. Next, list out common prime factors of both the numbers. Then find the product of all the collected factors, which is the HCF of given numbers. I know this is a little confusing, but it is very easy when it is explained with an example. So let me show you a problem or an example for easy understanding. See, here they have asked to find out the HCF of 24 and 30 by using prime factorization method. So, first we'll take number 24. Number 24 is divisible by 2. So, 2 12s are 24. 2 6s are 12. 2 3s are 6. So, the factors of 24 are 2 into 2 into 2 into 3. Then, same way, for 30, it is 2 15s are 30, 3 5s are 15. So, the factors are 2 into 3 into 5. So, here the common factors among 24 and 30 are 2 and 3. So, the HCF is 2 into 3, which is 6. So, the highest common factor of 24 and 30 are 6. Next, we'll take another example and find out the HCF of 43 and 12 by using prime factorization method. So first 43. 43 is divisible by, it is a prime number. So it is divisible by the same number and 1. That's all. So 43 is a 43. 43 ones are 43. Hence the factors are 43 and 1. Coming to 12. 12 is not a prime number. It is divisible by more than 2 numbers. That is 2 6 are 12, 2 3s are 6, 3 1s are 3. So factors of 12 are 1, 3, 2 and 2 to the power of 2. So here the common factor is only 1. Hence the highest common factor for 43 and 12 is 1. This is how you have to find HCF in prime factorization method. Hope you are able to understand. Any doubts you can mention in the comment section. I'll help you solving your doubts or resolving your doubts. Next, division method. The HCF of 2 or more numbers can be found using the division method by following below steps. Divide the larger number by the smaller number. If there is a remainder, divide the first divisor by the remainder. Repeat the same procedure until you get the remainder as 0. The last divisor which you get in this procedure is the HCF of the given number. So let me explain you these procedures with a simple example. So here they have asked find the HCF of 25 and 35 by using division method. So first you have to take the biggest number here that can be divided by 25. So here 25 is the smallest number and 35 is the biggest number. Therefore 35 is divided by 25. So 25 ones are 25. The remainder is 10. So when the remainder is 10, 10 becomes the smallest number and the divisor 25 becomes the biggest number. So the 25 is again divided with 10, divided by 10. So 10 2s are 20. The remainder is 5. So now 5 became the smallest number and the divisor 10 became the bigger number. So we'll divide 10 by 5. So 5 2s are 10. Here the remainder becomes 0. Therefore, the last divisor was 5. If you see here, the first we started with 25, then it became 10, then it became 5 and then 0. So before 0, the last divisor was 5. Therefore, the HCF of 25 and 35 is 5. Next, we'll take another example. Find the HCF of 55, 88 and 121. So, first we have to find the HCF of two numbers. Then, the last divisor of this between 55 and 88 is taken for 121 to find the HCF of all the numbers. So first we'll take first two numbers, we will take 55 and 88. The bigger number between these two is 88. So 88 is divided by 55. So 55 ones are 55. The remainder is 35. So 33 becomes the smallest number and the biggest number divisor is 55. So 55 is divided by 35, which is 33 ones are 33. The remainder becomes 22. Now, remainder 22 becomes the smallest number and the divisor 33 becomes the biggest number. So, 33 divided by 22, that is 22 ones are 22. The remainder is 11. So, 11 is smallest number and divisor 22 becomes the biggest number. Hence, again 22 is divided by 11. So, here 11 twos are, sorry, I have written 1 here. So, please make correction. It is number 2. So, 11 twos are 22. So, the remainder becomes 0. Hence, the last divisor is 11. If you see, the last divisor is 11. Before 0, it is 11. Hence, the HCF among HCF of 55 and 88 is 11. So, now we have to find HCF of 55, 88 and 121. So, we have to take 11 now. The last divisor 11 with 121 to find the HCF of these three numbers. Let us see how is it. So 11, this was the last divisor in the previous slide which you saw. So now consider 11 and 121. Among these, 121 is the biggest number. Hence, it is divided by 11. So 11s are 121. It becomes 0. Hence, here also before 0, the last divisor is 11. In the previous slide also, the last divisor was 11. Therefore, the last divisor 11 becomes the HCF of 55, 18 and 121. So, hope you are all understanding and it is very clear. Now we have solved the problems of both LCF and HCF in two different methods. Now we'll find out what is the relationship between the two numbers and their LCM and HCF. When two positive integers, let's say m and n, are supplied, the relationship between their HCF and LCM is equal to the multiplication of two given numbers as shown in the equation. Here you can see HCF of two numbers, that is m, n, and LCM of two numbers m, n is equal to m into n. In simple words, HCF into LCM is equal to m into n. This is the relationship formula for LCM and HCF. This you can understand in an easier way with the problem. In the next slides, in the upcoming slides, I'll explain you the problem so that you'll understand the relationship between LCM and HCF. So, find the LCM of 8 and 12 and hence find the HCF they have asked. So, first they have asked to find out the LCM. So, LCM of 8 and 12 by using division method, 8, 12, 2 4s are 8, 2 6 are 12, 2 2s are 4, 2 3s are 6, then 2 1s are 2. It is not, by using 2, you cannot divide 3. Hence, write as it is. Then use 3. 3 1s are 3. So, the factors are 2, 2, 2, 3. Hence, 2 into 2 into 2 into 3 is 24, which is the LCM. So, how to find HCF? The formula they have given, LCM into HCF is equal to M and N. So, we have to find HCF now. So, in the left hand side LCM, if you bring it to the right hand side, it will become divided by. So, the formula becomes HCF is equal to M into N divided by LCM. So, M is 8, N is 12. So, 8 into 12 divided by LCM we have found out as 24. So, 8 into 12 divided by 24 gives 4. Therefore, the LCM is 24 and HCF is 4. This is how you'll find out LCM and HCF by using the relationship formula in an easier way. Next, find the HCF. Now they have reversed the questions. In the last problem, we have found out the LCM first and then using the formula, we found HCF. But now we'll find out the HCF first and then by using the formula, we'll find out the LCM. So HCF of 25 and 35. Here the bigger number is 35. then 25 is the smallest number. So the divisor is 25. So 25 ones are 25, the remainder becomes 10. Then again, we'll take the previous divisor 25 and divide by 10. So 10 twos are 20, the remainder is 5. 5 twos are 10, the remainder is 0. The last divisor is 5. Hence, therefore, the HCF is 5 for 25 and 35. Now, we'll find out LCM by using formula M into N divided by HCF. M into N is 25 into 35, divided by HCF is 5. So, you'll get LCM as 175. Hope this is very clear. Next, we'll find out the LCM and HCF of two numbers are 144 and 12. They have already given the LCM and HCF. If one of the number is 36, find the other. So here, the two numbers M and N. In this one number, they have given 36 and they have given LCM and HCF. So we have to find the second number. So let us keep the second number as Y for our convenience to find out the number. So we know the formula HCF into LCM is equal to M into N. So HCF is 12 into 144 is equal to the product of two numbers. In that one number, we know it as 36 into Y. So therefore, Y is equal to 12 into 144 divided by 36. Therefore, the Y becomes 48. So this is how you find the missing number. If they have given only one number and given LCM and HCF, you'll get the you'll be able to find out the second number by using this formula. So the second number is 48. Next, HCF and LCM of fractions. So till now you had got the complete integer to find out the HCF and LCM. But if they give the number in fractions and ask you to find out the HCF and LCM, how will you find out that? We will see now. So if we want to know the HCF and LCM of fractions, then you have to apply the following two formula. For finding HCF of fractions, first you have to consider the numerators. So you have to do HCF for numerators and LCM for denominators. Same way, if they ask LCM of fractions, then LCM of numerator should be done. Then HCF of denominator should be done. So this result, the answer will be the HCF or LCM of fractions, which they have asked in the question. You'll be able to understand this easily in a problem. Let me explain you with an example in the next slide. So find the HCF of 3 by 5, 6 by 7 and 9 by 10. So first they have asked HCF. So when they ask HCF, you have to consider the numerators first and do the HCF for the numerator. Here the numerators are 3, 6 and 9. So first we have to, when there are three numbers, you have to consider first two numbers and find the HCF, and the result of the last divisor of those two numbers will be considered with the third number to find out the HCF. So here the first two number is 3 and 6. 3 twos are 6. You can see 3 twos are 6. The remainder is 0. So the last divisor before 0 is 3. So again with the 3, you have to do 9, division 9. So 9 is the biggest number. So 3 becomes the divisor. So 3 threes are 9. The remainder is 0. So the last divisor before 0 is 3. Hence, the HCF of numerator is 3. Likewise, you have to find out LCM of denominators. Denominators are 5, 7 and 10. So by using division method, 2 is for 5 and 7, it cannot be used to divide. So you write as it is. For 10, it can be done. So 2 5s are 10. The next number is 5. 5 1s are 5. Then again 7 is not divisible. Again, you have to take 7 since it is a prime number. 7 1s are 7. Hence, the LCM is 2 into 5 into 7, which is 70. So you have found out the HCF and LCM of the fractions, which is 3 and 70. So now HCF of fraction, how will you find out? The HCF of numerators was 3 and the HCF of denominators was 70. So 3 by 70 is the HCF of the above fraction. So the fraction 3 by 5, 6 by 7, 9 by 10. The HCF of these three fractions is 3 by 70. Next, find LCM of. In the previous problem, they had asked for HCF. Now they have asked for LCM. So when they ask LCM, you have to take the numerators first for that. So 4, 6 and 8. You do LCM for that. So the LCM is 2 into 2 into 2 into 3, which is 24. And denominators are 5, 10 and 15. For this, you have to find HCF. Though. So first two numbers are 5 and 10. 5 twos are 10. So the remainder is 0. The divisor, the last divisor was 5. So with 5, you have to put bigger number 15 and consider 5 as divisor and find out the HCF. So 5 threes are 15. So remainder becomes 0. So the last divisor was 5. Hence, the HCF for 5, 10 and 15 is 5. So we found out both LCM of numerator and HCF of denominator. So now we have to find out the LCM of the fraction 4 by 5, 6 by 10 and 8 by 15. So that is LCM of numerator divided by HCF of denominator, which is 24 by 5. So the LCM of those three fractions are 24 by 5. Next, find the smallest number which when divided by 20, 25 and 45 leaves no remainder. So here find the smallest number means you have to find the LCM of these numbers. That's all. And the remainder should be nothing. So first, by using division method, we will find out the LCM, the smallest number, 20, 25 and 45. So if you do, you'll get LCM as 2 into 2 into 3 into 3 into 5 into 5, which is 900. Therefore, the smallest number divisible by 20, 25 and 45 with no remainder is 900. This is how you'll find out the smallest number. In exam, they ask smallest number. It is nothing but the LCM. That's all. So there is no need to get confused or be panicked. So another example I have taken. Find the smallest number which when divided by 45, 48 and 72 leaves 2 as remainder. So that here you have to be very careful. In the previous problem, they told 0 leaves no remainder. But here they have asked 2 as remainder. Therefore, the smallest number which when divided by 45, 48 and 72 without a remainder, then the LCM is 720. So how you got 45, 48, 72 you'll write by using division method. 2 24s are 48, 2 36s are 72. Then 2 12s are 24, 2 18s are 36. 2 6s are 12, 2 9s are 18. Then 2 3s are 6. Then 3 15s are 45, 3 1s are 3, 3 3s are 3. 3 5s are 15 and 3 1s are 3. 5 1s are 5. So this is how you find the LCM. Then the LCM is 2 into 2 into 2 into 2, 3 into 3 into 5. So the number is 720. 720 is the smallest number which when divided by 45, 48 and 72 but leaves no remainder. But they've asked when it leaves 2 reminders. So here you have to be very careful. When the question asks to leave some number as remainder, then you have to add that particular number to the LCM. Here the LCM is 720 and they've asked to leave 2 as remainder. So add 2 to 720 which becomes 722. So this is the smallest number 722 with 2 as remainder. Next, find the greatest number less than 500 and divisible by 9 and 15. So in this problem, we have to find out the LCM of the given number 9 and 15 and then find out the multiples of LCM which is less than 500. So first, by using factorization method, we will find the LCM 9 and 15. So 3 3s are 9, 3 5s are 15. So 3 1s are 3, then 5 we have to write as it is since it is not divisible by 3. Then 5 1s are 5. So LCM is 3 into 3 into 5 which is 45. Next, now we have to find out a number which is divisible by 40, that is the LCM, which is 45, and also less than 500. So what you have to do here to find out the answer, you have to divide 500 by 45, which becomes 11.1111. So removing the fractions, the exact number which we can consider is 11. So the required number is 11. 11 into multiplied by 45, that is the LCM. 11 into 45 is 495, which is less than 500. Therefore, 495 is the number which is less than 500 and also divisible by 9 and 50. This is how you will find out the answer. Next, find the largest number that divides 163 and 99, leaving a remainder of 3 in each case. So here you have to be very careful. They have asked remainder as 3 and find the largest number. So first you have to deduct 3 from both 163 and 99 here. So if you deduct 3 from 163, it becomes 160, and 3 from 99, it becomes 96. So then you have to find out the HCF for 160 and 96. So the largest number is 160 and the smallest number is 96. So the divisor is 96. 96 ones are 96. The remainder is 64. Then this becomes smallest number, 96 becomes biggest number. So 64 ones are 64. The remainder becomes 32. So 32 becomes the smallest number and the previous divisor 64 is the biggest number. So 64 should be divided by 32. So 32 twos are 64. Here the remainder becomes 0. So the HCF is 32 because a number which is before the divisor before 0 is 32. Hence, the HCF is 32 and also the number which is required with the remainder of 3 is 32. Hope this was very useful and easy way to understand the LCM and HCF problems. Any queries or doubts, you can post it in the comments or also mail us to educatorguru@gmail.com. The email ID will be mentioned in the description. Kindly check that. And students who have not subscribed, kindly subscribe, like and share our video. All the best. Thank you.